Okay, so what we're going to do now is we're going to use the information that we previously went over. Okay, we're going to look at the 5 different types of reactions. We're going to use our knowledge of how to correctly write compounds versus elements. And we're going to use these patterns to help us figure out the products that are formed in a chemical reaction. So instead of me giving you the whole reaction and you simply deciphering it, putting it into chemical form, you will now just be given the reactants and you need to know how to predict the products. Okay, so in the process of getting there, we need to know a couple of terms. We're going to do them in different groupings based on the types that they are. And by the end, you should be able to predict what is formed in pretty much any reaction. All right, so we're going to break this down into two groups based on the way the reactions happen. We're going to focus first on our double replacement reactions. Okay, in double replacement reactions, everything always happens the same way. So once we learn how to do one double replacement reaction, we're going to do it the same way for all of them. Then once we've got that mastered, we're going to talk about the remaining 4 reactions. Okay, they all have things that happen a little bit differently. So we're going to handle those all at one time because again, it's going to be the same general idea for each of those. So first, let's focus on double replacement. So remember that a double replacement reaction always has 2 compounds to start and 2 compounds as products. In every double replacement reaction, also known as double displacement, we will be working with ionic compounds. Okay, so no need to look at your little flow chart because everything will be ionic. When I say ionic compounds, what do we think of? Ions which have charges. Okay, so when we work with these reactions, we will be losing the charges of the ions. Okay, every single time we have double replacement, we will work with charges. What happens is, because ionic compounds are held together by opposite charges, many of them, when you put them in water, for example, NaCl is an ionic compound, and when you put it into water, what happens to it? Just the general term that we use. It dissolves, okay? The scientific name for dissolving is dissociating, okay? Dissociation, dissolving is the same thing. And what is actually happening, even though we can't see it with our eyes, is the water is pulling apart the sodium and the chlorine from each other. When you separate an ionic compound, you have ions. So what really floats around in the water is the individual sodium and chlorine ions when it dissolves or dissociates. Okay, so basically we're going to put this compound in water to make it aqueous. We're going to put this compound in water to make it aqueous. And we're going to say, now let's mix it up, shake it up, and see what we end up with as a result. We'll talk about the patterns of forming shortly, but we're just going to go over the basic terminology first. So you may notice in this that you can see that A and C have switched places. Okay, so instead of A being with B, now C is with B and A is with D. So essentially, in a double replacement reaction, your 2 positive ions trade partners. What would that look like? Well, if we were reacting NaCl with KBr, and now K and Na trade partners, K will pair up with NaCl, and Na will pair up with Br. We'll go into more detail about that process, but I just wanted to generally let you see what's going to happen here. Okay, so these are the bullets now on page 10 underneath A. We have two specific types of double replacement reactions. When we go to predict the products, it's not going to matter. We're going to predict the products the same way. This just is how we label them so we know what's happening. The first type is called a precipitation reaction. In a precipitation reaction, we're going to take two aqueous solutions. So in other words, ionic compounds that are dissolved. We're going to mix them together, and we're going to find out that one of the products will be a solid, also known as a precipitate. When we did the evidence of chemical change lab, the very first reaction you did when you took your copper to nitrate and mixed it with the NaOH, that was a precipitation reaction. And you should have seen like a jelly-like floppy substance kind of form in your test tube. Okay, that was a precipitation reaction. So the trick to knowing when you have a precipitation reaction is that one of your products will be a solid, aka precipitate. We'll talk about how we know the states of matter later in this lesson. Okay, again, it is just a double replacement reaction. Compound plus compound produces compound plus compound. The only thing that makes it special is that a solid forms. The second category of double replacement reaction is called an acid-base reaction or an acid-base neutralization. Again, just a double replacement reaction, compound plus compound produces compound plus compound. But in this type of reaction, no solid forms. Okay, you can see we have an aqueous and a liquid. But what does happen is an acid and a base will neutralize each other, or their pHs will basically come to the middle. So how do we know when we have an acid base? Well, acids start with H. HCl, HNO3, H2SO4, H3PO4. So if you have an acid and it reacts with a base, how do we know have a base? Well, bases have a hydroxide group. So this is a base. The two products will always be the same in general terms. One of the products will always be water. Can anyone see where the water comes from? The H and the OH. HOH, remember we rewrote that in our balancing. And then the other product comes from the other two ions. In this case, we have a sodium ion and a chlorine ion. We give the general term to the other compound as a salt. Okay, we said that a salt is really any ionic compound. So there you go, there's your any ionic compound. So essentially, we take two very hazardous substances, an acid, which can burn your skin and eyes, a base, which can burn your skin and eyes, will kill you if you drink it, and we make salt water. Okay, so chemical reactions are pretty amazing. All right, so now let's talk a little bit more about the specifics of these reactions. Okay, so back to precipitation reactions. We mentioned that precipitation reactions form a solid. Okay, so in order for the reaction to happen, you need dissolving to occur. Okay, the ionic compounds that go into the reaction have to be dissolved because you have to have free floating ions in the water. When the ions are connected to each other, they can't react. So if they don't break apart, then no reaction will happen. So If we put salt in water, again, we're going to see sodium ions floating around. We're going to see chlorine ions floating around. If we were to pour something else in there, for example, AgNO3, okay? Again, it's going to break apart into its ions, and you would have silver ions and nitrate ions floating around. This is what allows reactions to happen, because once they are broken apart, they can socialize or mix up with other free ions to form new compounds. Okay, so anything that is aqueous will dissolve. But not all ionic compounds can dissolve. So for example, if you were to put PbI2, also an ionic compound, in water, it would not dissolve. It would remain a solid. And so when we go through these reactions, as we mix up different ions, even though they may start as aqueous, if they combine with a new ion and form something that does not dissolve, we're going to see a solid form. So that is why we see solids in these reactions. Okay, so something that does not dissolve remains a solid or becomes a solid if the combinations are right. Notice when it is a solid, we don't write the ions because it is still part of that compound. Okay, couple of terms that we're going to use. So we've been talking about dissolving. When something dissolves, we use the term soluble. Okay, soluble just means it's able to be dissolved, able to be broken into its ions. And the state of matter for something that is soluble, something that can be dissolved, is aqueous, AQ. Insoluble means not soluble. So this is something that cannot be dissolved and it will form a solid. Okay, so these would be your precipitates or the solids that form in the reaction. I took off the term electrolyte, so even though it's in your packet, we're not going to discuss that. But just so you know, an electrolyte is just a free-floating ion. So those would be your dissolved ions. The precipitate then is the solid that forms in a double replacement reaction. Okay, so insoluble, precipitate, and solid, they all go hand in hand. All right, so as part of this chapter, we need to be able to detect when a precipitation reaction has happened. In order to be able to do that, we need to know if a solid forms in the reaction. Okay, so the next thing we're going to do is learn what are called solubility rules. So solubility is the things that dissolve. Insoluble means they don't. So the solubility rules came up by trial and error. Okay, the best way to figure out something dissolves is simply put it in water and see if it dissolves. So over time, Scientists developed a set of rules. They noticed certain patterns about what things dissolve, what things don't. And this is the table that we're going to use to allow us to predict if something will form a solid or not. Okay, so we are going to first learn how to use these rules, and then we'll put them into our chemical equations. All right, in your packet, you will see some solubility rules. You do not need to memorize these. They are also on the back of the periodic table that you will have for every test. Okay, so these match those. If you were to go online, you might see different versions of the solubility rules, but they all basically say the same thing. I find this one to be the easiest to interpret, which is why we use this one. There are two parts to this table. First, it talks about things that are mainly water soluble. Remember that soluble means dissolves. And the state of matter for something that is soluble is AQ. Insoluble means does not dissolve. And the state of matter is solid, also known as the precipitate. The left side gives you the substance or portion of the substance that you are looking at to determine solubility. You will notice that they all have negative signs. Okay, so they are all negatively charged. That means that the part of the compound that determines solubility is the negative ion. In a chemical formula, which part is the negative ion? The first part or the second part, Chris? The second part. So for example, this is my negative ion. So you always look at the second half of the compound. You find it on the chart. And then you read the rule. So the rule for my NO3, which is my nitrate, is that all nitrates are soluble. So that one is a very straightforward rule, which means that the state of matter must be aqueous, okay? Because soluble means aqueous. Some of them are straightforward. There's only one rule. Many of them have exceptions. So let's look at how we deal with the exceptions. So for example, here are two chlorides. Yes. Yes. Two chlorides. So this is the rule we're going to follow. It says all chlorides are soluble except. Okay, so that means if it is not one of these exceptions, then it's soluble. If it is an exception, it is the opposite, which is insoluble. So NaCl is soluble because it is not an exception. AgCl, however, is the first exception, which means it's not soluble or insoluble. So that would be a solid. Does everyone see how we read that? Okay. These down here get a little bit more confusing because instead of listing specific things, it talks about groups. So for example, okay, so here's the first one. So they both have sulfur. So we're going to use the sulfur rule. Since all sulfides are insoluble, which means solid, unless it's one of these. Now it says, except for those of groups 1 and 2, and the specific one with the ammonium ion. What do we mean by groups 1 and 2? On the periodic table, which of our element in this compound would be on the left side of the periodic table? Chris. The first element, okay, because these are metals. So you check for the location of your metal. And if it is in group 1 or 2, then it is an exception. So aluminum is not in group 1 or 2. So therefore, aluminum, this would be a solid that would form. Calcium is in group 2, which means it is not insoluble, it is soluble. So this one would be aqueous. Okay, so it's really just a matter of carefully looking through and interpreting the rules.